tell us the origin stories of this company. Why did you start it?
I was introduced to cyanobacteria by a neighbor who was a professor at Arizona State University. And so we began working with cyanobacteria. And we worked on it for 5 years. I had a team of PhDs and biologists that carried out the development work. Our purpose of the pilot facility was to demonstrate both the production system and the strains and what we could use them for commercially. And so the final conclusion was that the highest and best use was literally as a soil amendment in restoring depleted soils. And so then 2015, we formed Biodel Ag based upon this discovery of this other plant extract. Once we got that business moving forward, then it was time to develop a product and a brand that would be under Biodel Ag, which we began working. Again, we pulled the work with cyanobacteria off the shelf and began pulling or performing large-scale field trials, and found out, just as we had found out earlier, that the cyanobacteria was a tremendously effective tool in restoring or rejuvenating depleted soils, sequestering carbon. And so the emergence of the regenerative agriculture movement that's going on worldwide to basically rebalance our atmosphere of its carbon content is what drove us to develop this product.
Okay. So in terms of, we'll go into the business, but I want to talk a little bit about the green tech here too. So you mentioned its impact on pesticide use. So when you say that, you mean you would use much less or no conventional synthetic pesticides if you're applying this. Is that accurate?
Well, let me back up a minute. I think I've confused here. The plant extract that we discovered, which was the basis of founding Biodel Ag, that product has biopesticidal qualities.
Okay.
Sequester as a product is really designed to restore soil health. Does it help with pesticide or insects and the like? It certainly helps anytime the soil is able to support a healthy crop. But those are two separate products.
Okay, great. So this is somewhat of the next iteration of the technology. Is that accurate to say?
Yes, very much so.
Okay. And let's talk a little bit about the team. Who was on the team? My understanding is you guys are the rock stars of ag. Can you tell us a little bit about the other team members?
Well, I don't know about the rock stars of ag, but we certainly have some really great talent that has contributed significantly to our product development and moving us into the marketplace. One of those individuals is a gentleman by the name of Kent Adams, and he's a microbial specialist. He really understands the microbial world, especially as it relates to agriculture. And he has been very beneficial in helping us. He came from a company that and a background where he's helped to manage national accounts in moving these kind of products into the market on a large scale. So he's been a real asset. And then the other individual that really is a key individual in our work is Dr. Paul Zorner. And Paul is a plant specialist by training. He's a professor at North Carolina State University, adjunct professor, but he's also been involved in the evolving work and establishing the protocols for how we can sequester carbon in agricultural soils. And so that has really been beneficial to us in how we position our product, measuring our capabilities and the like, and opening this door to a really large market opportunity.
Great. All right, so let's circle back to the technology. So you mentioned it does two things, and this might be easy to overlook, but restores soil health, which is a huge deal in North America, I imagine all over the planet, and captures CO2. Can you just talk a little bit about both of those, and perhaps, again, not a deep dive, but a little bit how the technology actually does those two things?
You bet. Let me go through that. Number one, most of our agricultural soils, because of the way we have farmed for the last 75 years, has literally depleted what's called the soil organic matter in the soil. And the lower the soil organic matter, the less carbon is held in the soil. And in fact, agricultural lands have actually been an emitter of carbon when normally soils should be a sink. In other words, we should be cycling carbon back out of the atmosphere, but because of our agricultural practices, we've interrupted that cycle.
Okay.
And so our product in particular helps to restore, number one, what's the microbial biomass in the soil, so that the function of the soil returns. And anytime you're growing a crop, we're literally taking sunlight and carbon dioxide out of the atmosphere. It's converted into plant sugars. Those plant sugars are released out of the roots of the plant itself to draw the microbial interactions. And what that activity does is that what's left over after the sugars are consumed are a stable form of carbon. And that is what we're seeking to achieve in the soil. Crops can lay down tremendous volumes of carbon if the cycle is not interrupted by using synthetic fertilizers, things of that nature, that tend to kill off or are antagonistic to the microbial biomass in the soil. So soil is a living thing. We have to have that microbial relationship with plants. It's synergistic. It's the way nature designed it, and it's very effective in pulling down large volumes of CO2 out of the atmosphere.
And how, again, give us the cliff notes for those of us who aren't soil scientists. How does the bacteria increase this uptake?
Well, cyanobacteria in particular are credited by NASA, for example, for creating our atmosphere, the atmosphere we live in today. And that is going from a carbon dioxide dominant atmosphere to an oxygen based atmosphere. So that was some 3.5 billion years ago. So these organisms are really effective and durable and hardy. They live under very severe conditions of extreme temperatures and extreme cold temperatures as well. And so their function really is to, they're what are called, technically what we call a photosynthetic autotroph. And as an autotroph, it means they bring their own energy to the game as far as the microbial activity in the soil, which drives all the other microbes, bacteria, fungi, protozoan, nematodes, drives the entire cycle in the soil, and again facilitates the improvement of the soil organic matter in the soil year over year, and the overall function of the soil improves as that soil organic matter increases. So by simply applying this one type of organism, which are, again, I like to call them the D10 caterpillars of the microbial world. They're the heavy lifters. And all the other cycles and interactions are driven by the energy they bring into the soil profile.
Can you call them a catalyst or a kickstarter or jump starter of the biome? Would that be accurate, or is that too broad?
That has been their history.
Okay.
And how they're applied. Cyanobacteria are in every spoonful of soil that you could ever find on Earth. Okay. And so by culturing up the strains that we culture and applying them, we're in essence doubling, per se, the amount of that organism in the soil profile. So it has a very positive impact on all the rest of the microbial activity, which then breaks down the sand, silt, and clay particles and captures the minerals that are needed, the interactions that generate nitrogen, phosphate, potassium. All these other things are driven by this microbial process. And cyanobacteria in particular are very efficient and effective in driving that process. One other factor I just might mention is that they are nitrogen fixing. So when we apply this, it naturally takes up and produces nitrogen that's available to the crop.
Okay, so nitrogen again, I'm not a scientist, so correct me, but
yeah,
N2O is also a greenhouse gas that's addressed by the Paris Accords, isn't it?
Yeah.
So you're saying it sequesters it in the soil rather than releasing to the atmosphere.
Exactly. And you know, to pull nitrogen out of the atmosphere requires a rather energy intensive chemical reaction. That's how we make fertilizer synthetically. And so these organisms are able to do it directly.
The Bozeman-Hicks, I'm getting it wrong. What's the name of the process?
I think you're speaking of the Haber-Bosch process.
Yeah, is that the process you're talking about?
Yes.
Okay, so it's got to be done at great temperature, at great atmospheres, and a tremendous amount of energy input, is my understanding.
When you're making a synthetic fertilizer, yes, that's what's required, a tremendous amount of energy.
Okay, so we've been doing it that way for about 80 years, right?
That's right.
Okay, so this is a more natural way to actually fix the nitrogen without having to create this kind of a super blast furnace of great temperature and atmospheres.
That's correct. And it all occurs within the soil profile. You don't have to produce this or use other energy sources off site. You don't have to transport it to the field. All you do is put on a few hundred grams of this material in liquid form. So it goes out in 1 or 2 gallons applied per acre and generates the positive benefits that we're speaking about.
A couple ounces per acre?
No, a couple of gallons.
Oh, gallons. Okay. Okay, gallons.
When I speak of we measure the cyanobacteria on a dry weight basis. So we look at it as grams per acre.
Gotcha. All right, let's segue to the business. It's going to be a little bit of a speed round. We got 6 minutes. So I'm reading some notes from the campaign page. It says, so you have revenue. I mentioned that because there's campaigns that are pre-revenue companies, but your revenue is 561,000. Says past year. Does that mean 2021?
Yes, 2021.
Okay, and that was up 144% from the year before.
Right.
And that's obviously during the COVID pandemic. So I imagine doing business was challenging.
Well, certainly, but agricultural products like this being delivered to the marketplace, they take years to develop. And so we've been making very good progress. The purpose of our capital raise right now is, quite frankly, to generate the market side of this and the advertising that's necessary to move us into the marketplace on a strong basis. We have tremendous marketing and production capacity. We've got cash flow, but 2023 is really our year that we're really going to be marketing strongly. And originally it was going to be 2024, but the reason we have moved that up is because here in Arizona and California region, we're experiencing tremendous drought conditions, and it's motivating farmers to look for products like ours that do 3 essential things, which is reduce salinity and reduce the amount of water that's required to irrigate a crop, and also reduce the amount of fertilizers that need to be purchased. Okay. And so we accomplished those 3 things. So we moved our marketing plans up a year, which is why we've moved forward with this capital raise.
Fantastic. And that was really my final question is how do you make money and who are your clients? Are they farmers and ag consumers?
Well, we pursue three market categories. The largest by volume, of course, is selling to commercial crop producers. And generally, that is how we reach those customers is through what are called ag distributors. These are large companies that service their agricultural customers throughout the country, throughout the world, in fact. And so we market to them. We also market to crop consultants directly to introduce our product and its capabilities. And sometimes to the larger growers, we can talk to them directly. But generally, it's through this ag distribution network that's well established. The other category we market to is what we call the home and garden small farm category.
Okay.
And that's because if you're growing a lawn even, you can actually begin sequestering carbon and improving your soil health by using our product, or your landscape or your garden, any of those uses. And so we have a website that we market that product on, and it's called sequester.ag, sequester.ag. And our third category, real quickly, is where our greatest growth potential is long-term, and that is marketing to large ag land owners who are looking to position their properties to sequester carbon and be compensated for the carbon that is sequestered over time. And so for those customers, we look to negotiate a 5-year term contract where we can effectively transition their property from conventional or synthetic-based fertility and the like to a regenerative approach. And so those are our three primary market categories.
Great. And we've got about a minute and a half. So I want to ask you, how big is what would you define the market as? Is it all of ag? And then it sounds like all of carbon capture that's coming up. How big is this market exactly?
Market's unbelievably huge. Our governments around the world are literally going to spend trillions of dollars in the ag market to promote the sequestration of carbon out of the atmosphere. And so over the next 25, 30 years, our objective is to position our customers, our growers, to be able to capture that value. But to give you just an example, for example, in the United States alone, the United States has about 450 million what are called intensively farmed acres. That means acreage where inputs are applied. And so right now, today, less than 5% of that, or about 20 million acres, would fall under the category of regenerative grown crops that can sequester carbon. So we have the other 95% of that acreage that we've got to transition over the next 20 to 30 years. And so to meet the CO2 sequestration goals of our government. So that's an example of how large the market is. We have a long way to go and a great opportunity.
Fantastic. Let's end on that kind of positive, happy note. And if anyone has interest in talking to you, I can see you can invest as little as $250. If anyone has an interest in investing $1,000 or more, can they set up a call with you, a 15-minute call to talk about it?
Absolutely. We're glad to speak with any prospective investors and look forward to talking with them all.
Great. I'll include your Calendly link in the email that's sent out. Thanks so much.
Really appreciate it, Patrick. Thank you.